Hi, my name is Hazim Gaber, and today we're going to look at subnets and subnet masking and subnetting. So, I guess where we can start is why do we need to have a subnet? And the answer goes back to our example of our enterprise network. And so remember that we had about 4 billion IP addresses, which wasn't enough. So our router or our modem or whatever has a public IP, and then it's on our router quickly. And then, so if we cut this in half, this is a private side. And so we have all these devices with private IPs. And so we need to be able to subnet them. And the reason is every device on the network needs to know its subnet so it can understand if another device is on the same network or a different network. So remember, I have a computer and I have a printer and I have a laptop which is on Wi-Fi, and I have another device out here in the cloud, another destination. So how does the PC determine? So say the PC knows the address of the printer or the address of a laptop or the address of a router that's on an external network. How does it know that the laptop and the printer are internal and that the other device is external? And the answer is with the subnet mask, of course. And so the next thing we're going to think about is what we call the network ID. So actually, the next thing we're going to look at is how computers count. So remember that there are 8 bits in 1 byte, and computers are only on and off. So the way a computer counts is it has these things called buses, and there's 8 of them, and it either turns them on or turns them off. So the first one is worth 1, and the second one is worth 2, third one's worth 4, fourth one's worth 8, 16, 32, 64, and 128. So if all of these are on, so then the total, add these together, is 255. And if they're all off, the total is 0. But I could do any combination. So 1, 2, 4, 8, 16, 32, 64, 128. Turn this one on, this one on, this one on, this one on. So now it's 2 plus 8 plus 32 is 128, which is 170. So it's very important to understand this because this is a fundamental way to know how a subnet mask is expressed. And there's three ways to express a subnet mask. So if you've seen, say your IP address is 192.168.0.1 example, and your subnet mask can be written as /24, so it's a number, or it can be written as 255.255.255.0, or it can be written as 11111111111111111111111111111111111. 1, 2, 3, 4. Okay, so how did I get all these numbers, and what the hell do they mean? So, in the longest form, a subnet mask is 32 digits long, and they're ones and zeros. So, in this case, I have 24 ones and 4 zeros. So if there's 24 ones, then that means that this is a /24. And then remember from before, we call this an octet. So this is the first octet. This is the second octet. This is the third octet. This is the fourth octet. And this corresponds to this, and this corresponds to this, and this corresponds to this, and this corresponds to this. And this is basically number of ones. Now, if you do this enough, and somebody says /24, you'll automatically know it's this. So remember now, 5, 6, 7, 8. So to get 255, I got all ons or all ones here in our example. 128, 64, 32, 16, 8, 4, 2, 1. So if I add all these up, I got 255. And if they're all off, I get 0. So we call that, so that's how we can convert the numbers. And the numbers, once you've figured out the math is the hardest part. But we can have a number different ways of doing things. I want to come back to that. So and we're gonna learn how this works too. But basically, we have 3 classes of networks, and they're class A, B, and C. And so class A, is basically 1.0.0.0 to 126.255.255.255, and class B is 128.0.0.0 to 191.255.255.255. Class C is 192.0.0.0 to 223.255.255.255. And so number of hosts. There's also class D and E, which we're not going to talk about right now, but the number of addresses in a Class C network is 254. Number in Class B is 65,534. And the Class A it's 16,277,214. Now, if you look, you're going to say, well, from 192.0.0.0 to 223, that's a lot more than 254. So, what are you talking about? What I'm talking about is subnet mask. So, I can create a network and call it 192.168.0.0/24. And that's a 254. The width of that is actually 256 addresses, but we can't. The first address in the range and the last address in the range can't be used. So if I had a Class B network, let's say it was 129, for example, I don't have to start at 128. I am 129.0.0.0/16. So this network range has 65,534. And here's why. So let's say I gave you a network that was 192.168.0.0/24. Now, if you write out the subnet mask, you can convert it, can write out 24 ones, basically. Oops. And fill the rest. So then you could say, well, what is this? Well, 255.255.255.0, or in other words, I have a block at the end. So this block is from 0 to 255. That's what's missing. And that's my network. And so my network is 256 wide. And the first address in the network is a network ID. So we're not allowed to use that. So if my network ID is 0, it can't use. So 192.168.0.0 can't be used. And the last address is the broadcast ID. So that's 192.168.0.255. We're not allowed to use that one either. So that leaves us with 254 usable addresses. So we go back to the, say, Class B network, which was 129/16. So 129.0.0.0, or whatever, say it was 1/16. You write out 16 ones. So now this is So what did it take again? 255.255.0.0. And then based on that, we know that this portion is a network, the 0 portion. And how wide is it? Well, it's 256 times 256. Right? So 0 to 255 is 256 numbers. So now we know our network is 65,536 wide. And so if the first address is 129.1.0.0, then our last address will be that plus 65,000, so it'll be 129.1.255.255. And our first address is the network ID, so 129.1.0.0 can't be used. And the last address is a broadcast, which is 129.1.255.255, and that can't be used either. So that's it in a nutshell as far as classes of networks go. And so it's not that complicated. Now, if you're assigned this 129.1, for example, your neighbor could be assigned 130.1.0.0/16. And then his network would be 130.1.0.0 to 130.1.255.255. But now, so far we've seen the subnet masks as /8, /16, and /32, which makes our mathematics very easy. And the reason is because we have a full octet that's either all ones or all zeros. So when it's all ones, it's 255. When it's all zeros, it's all zeros. It's just a 0. And we can figure out the size of the network very quickly. But what happens when we have an address that's, say, /19 or /23? Then what do you do? And that's what we're going to find out next. So now we're going to look at why this is actually called a subnet mask. And so I've drawn a PC with the address 192.168.4.7/24, and 192.168.4.8 is the printer, and our router will probably be 192.168.4.1, and we've got another device out in the wild that's 5.2. It's also a /24. So remember our boxes: 3, 4, 5, 6, 7, 8, and this is 128, 64, 32, 16, 8, 4, 2, 1. So I can write 192 as a bunch of numbers. So 192.168.4.7 is 128 plus 64. Think about it. So if I go 128 plus 64, That's 192. So for my first octet, I'm gonna go 11000000, and then 168. So you can go 128. Just gonna erase this. Let's do this now. So we're gonna go, oops. So 128. Now I can't add 64. If I add 32, I get 160, and then I just can't add 16, so I just add 8, and that's 168. So that's 101010000.4. So 4 is pretty obvious. Let's go back to the eraser. So 0, so we're just checking off 4 now. So it's 0.7. So 7 is 4, 5, 6, 7. So it's 0, 0, 0, 0, 0, 1, 1, 1. And then we can also write out 4.8. So we already know first portion. And then 8 is pretty obvious. So if we just go eraser. So 0.0.0.0.1. Oops. My mistake here. This is 4, so we're writing out 4, 1, 0, 0. And then 8 is 0.0.0.0.1.0.0.0. So now we can write out our subnet mask, which is 255.255.255.0, which is 1111111111111.1111111.0.0.0.0.0.0.0. So the trick here, if you want to know if two addresses are in the same subnet, you write them out in binary, which I just showed you how to do. You write the subnet out in binary. Now remember, the subnet, all the ones will be on the left and all the zeros will be on the right. If you've got zeros on the left of the 1, then did something wrong. And so I'm gonna draw a line between the 1s and the zeros. So if two addresses are in the same subnet, then anywhere the subnet contains a 1, the two addresses will match. And anywhere they contain a 0, they may match or they may not match. So in this case, 4.7 and 4.8, they match completely on the left side where the 1s are. They don't match on the right side, which is fine. We try to write out 192.168.5.2. We'd write out 11000000.1010100.5. So how do I get to 5? Well, I get 4 Whoops. I erased too much here. 4 plus 1. So that's 0, 0, 0, 0, 0, 1, 0, 1. So this obviously doesn't match either of those two. And then dot 2, so it'll be dot. We don't have to continue, but even if we wanted to, let's just do 0, 0. So we know 5.2 is not in the same subnet as 4.8. Now, the real question is, if I gave you the address 4.7 and it's a /24, how do you know the width? Well, you know the width is from the subnet. So this piece right here is 256 wide. But how do you know the network ID? Because I didn't give you the network ID. I just gave you 4.7. How do you know where it starts and where it ends? And the answer to that question is you have a subnet mask. So this portion, anywhere there's a 1, you take, we're gonna just forget about this address now. I'm gonna forget about this address now. And we're gonna do what we call masking. So anywhere that my subnet mask contains a 1, so I wrote my address out in binary and I wrote my subnet out in binary. So anywhere that there's a 1, we bring down our address. So 1100.0.0.0.000.000.000.100. Anywhere there's a 0, we just write 0. That becomes our mask. So we ignored all these 1s here. And then we convert this back to decimal. So it's pretty obvious what this number is, and what this number is, and what this number is, because we did a bunch of them. So this is 1982.168.4. With the row of zeros is 0. So we know now that our network ID is 192.168.4.0. So that's our network ID. And our first usable will be the first one is 4L1. And our last, we know that it's 256 wide, so 192.168.4.255.56. 55 is our podcast. So, and that's how we calculate a subnet mask. Now, I don't really care for this formula, but some people do. So there's another way to calculate the 256, and that is figure out how many spaces, how many numbers there are at the end of the subnet. And we call these, how many zeros, and we call these x. So we have a formula that's 2x minus 2, where x is the number of zeros. So 2 to the 8 in this case, minus 2 is 254, which is 2 times 2 times 2 times 2, etc., minus the 2 for the network ID and the broadcast, which we're not allowed to use. So you can remember this formula, and it's going to be a little bit more handy once we start looking at a subnet that's, say, at /23. Because what do you do? Because if we had a /23, for example, now I'm going to draw our boxes again. What if I gave you 192.168.7.2/23? So, well, you can write this out in decimal. So how do I write 192.168.7.2? How do I write out /23? Well, 23 is easy. So it's 23 ones. So 1, 2, 3, 4, 5, 6, 7, 8 dot 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7 0 dot 1, oops, 0. So erase that. So with 23 ones, and since we're 32 wide, we're always 32 wide. So we get 23 ones and 9 zeros. So 2 to the x minus 2, 2 to the 9 minus 2 is 510. So this case, our network is 510 wide, because it's a weird length, but you can write 7.2. So remember 192, we go 128 and 64. So we're 1 1 0 0 0 0 0 0 dot 168. I'm gonna be lazy here. 1 0 1 0. So 1 0 1 0 1 0 0 0 dot 7, which is 4 5 6 7. So 0 0 0 0 0 1 1 1 dot 2, which is 0 0 0 0 0 0 1 0. So now, if I want to figure out the size of my network, again, anywhere there's a 1, I'm going to write down 1 1 0 0 0 0 0 0 dot 1 0 1 0 1 0 0 0 dot 0 0 0 0 0 1 1. In this case, notice there's a 0 here in the subnet, so I'm going to write a 0. And then obviously all these will be zeros. 3 4 5 6 1 0. So now we convert this back to decimal. We know this is 192.168 dot. Now we'll be careful here because this is not 7. So we go back to our boxes. We got 0. So and look at our box now. So our first box is a 0. Second box is a 0. Third is a 0. Fourth is a 0. Fifth is a 0. Sixth is a 1. 7 is a 1. 8 is a 0. So we got 4 and 2. So that gives us 6. And then here, you can do the same thing. Whoops, I messed up. This should have been a 0. Because we never should not have carried the 1 here. So this is all zeros, so 0. So our network in this case starts at 192.168.6.0, and it's a slash 23. From our formula, we know that it's 510 usable addresses, but if we know 2 to the 9 is 512, or in other words, if you wanted to, you could. So 2 to the x tells you how big your network is, and 2 to the x minus 2 tells you the size of the usable IPs. So to know what the last address is in this network, you can tell just by looking at it that it's going to be 192.168.7.255. But if you couldn't tell by looking at it, then there's another way, and that way is to flip the subnet mask. So if we flip the 1s into 0s and the 0s into 1s, actually, second way is 2 to the x. So you know 2 to the x is 512, and you can just add 512 to this. But since these only go up to 255, the maths are kind of tricky. So the third way is you flip the subnet mask. And so you write out to turn a 1 into a 0 and a 0 into a 1. So 0, 0, 0, 0, 0, 0, 0, 0, dot 0, 0, 0, 0, 0, 0, 0, 0, dot 0, 0, 0, 0, 0, 0, 0, 1, dot 1, 1, 1, 1, 1, 1, 1, 1. And now this is convert this back to decimal. So this is 0, and this is 0, and this is 1. Obviously, because you're just checking the 1 here, and then this is 255 because it's all 8 boxes are checked. And then you can add that to your network ID. So 192.168.6.0 plus 0.0.1.255 gives us 192.168.7.255. Any questions so far? So let's say I'm a really big ISP and you're a small ISP, and I give you a network, let's say 11.46.21.0/24, and you want to give it out to your customers who are even smaller, and you can make subnets out of it. So the first thing you want to do to understand this, because these can go even bigger, up to 31. So I'm gonna make some boxes again. We're gonna write this out in binary. And so we know our 24 is 1, 2, 3, 4, 5, 6, 7, 8. Now to get 11, you do 8, 9, 10, 11. So you go 0, 0, 0, 0. So 8, 9, 10, 11, so 0000.1011.46. So to get to 46, I get, we know 32 is smaller than 46. So we go 32 plus 16 will take us over, so we go plus 8, which is 40. Plus 4 is 44, plus 2 is 46. So 001011110.21. So we go 16, 4, 1, 000010101 dot, and then the rest are zeros. So now you can decide how you want to split this network, and think about every network you split, you now have one broadcast and one network ID which you can't use. So I've been saying IP, I've been saying ID and writing IP. But so you can split this into a bunch of different ways. You can make it, if you gave this whole thing away, it wouldn't be possible because part of it's yours. So you can make a /24. You we can split it into /25, /26, /27, /28, /29, /30, /31. You cannot make a /32 because then this would be all ones and the network would basically have no usable IPs. So if you had really small customers, you could pick a /31. And so now let's go to the next page, 11.46.21.0. So let's go 11.46.21.0/24, and we're deciding from /25 to /31, 1011. So we're gonna do some math here. 1011 dot 01110. So 0010110 dot 000010101 dot 0, and then 0000000. Oops, that. So we get, so if we look at this portion of our subnet mask, it's ones. It's not going to change. The only thing that can change is that we're going to add more zeros here. So they call this the default subnet mask, and then this piece becomes the extension or network ID extension, and these are called the hosts. So you already know. So if you chose, let's say, 30, for example. So I'm gonna make a /30 here, and we're gonna write out 30 ones. So you already know these are 24. Oops. And now I'm going to use my mask. So I'm going to bring this portion down. So this is 11.46.21, which I already know because I rewrote this. We're just rewriting the binary and converting it. If I wanted to, I could do it again. So if you wanted to see, let's undo this and just do it again. Do it again for the slow people. So we created our /30 mask. And now I'm gonna copy it. So 0.001.011 dot 0.0101110 dot 0.001.01101 dot, and they're all zeros. So remember my boxes: 2, 3, 4, 5, 6, 7, 8. So now I still have, I didn't change anything. So my first network is still 11.46.21.0, but now it's a /30. And if we look, it's only got 2 zeros. So if we use our formula 2x, where x is 2, so 2 to the 2 is 4. So that means this network is only 4 wide. So you can think about right away, you know 31 has 1 0, and 30 has 2 zeros, and 29 has 3 zeros, which is 2 to the 3, which is 2 to the 3, which is 8. You can figure out right away how big of a network we're going to end up with. In this case, 11.46.21.0 plus 4 gives us 11.46.21.4 as our network. And the first address is useless and the last address is useless. Sorry. 0, it's 4 wide, so this shouldn't be 4, so it should actually be 3, because our network is 4 wide. So 0, 1, 2, 3, 4. So it's better to do it mathematically because it'll trick you. If I had written this as a bunch of zeros, if I flip the mask over, I would only have 2 ones here, and this whole octet would have been 3. And when I added to 21.0, I would have ended up with 3, which is correct. So, and this one's useless. So we've got basically 4 IPs here: 11.46.21.0, 11.46.21.1, 6.21.2, and 11.46.21.3. And so this one's useless, not useless, but this is a network ID, and this is a broadcast. And so naturally, my next network, so I can write all these out. So I can go, my first network's 11.46.21.0/30. And I can go 11.46.21.4/30. And I can keep adding 4. So 21.8/30. And I can go on till my last network in the 21.255 is my last network. And so I quickly figured out that I have a lot of small networks. So I took a space of 256 and I turned it into a space of only 4, with only 2 useful. So we've basically wasted, in a way, half of our IP addresses. If we split this, say, in half, and made this a /25, then we'd end up with 2 networks, each 128 wide, each having 2 IPs that can't be used for a total of 4. So we would have conserved a lot of addresses. Now, how many you can quickly figure out how many networks you're going to end up with. And you can do that because you know original width is 256 and the new width is 4, so you just divide and you know you get 64 networks, each 4 wide with 2 usable IPs. Now, the last thing I should mention is we don't necessarily have to split this thing into equally sized subnets. I can make a bunch of different subnets. So if I go 11.46.21.0/24, I draw my boxes. I go 128, 64, 32, 16, 8, 4, 2, and 1. And then we draw 11. So remember 8 and 10, 11. So we go 0, 0, 0, 0, 1, 0, 1, 1.46, which is 0, 0, 1, 0, 1, 1, wait, 32, 0, 40, 0. Whoops. That's why it's always good to have a diagram. 1, 0.21, which is 16, so 0, 0, 0, 1, 0, 1, 0, 1 dot. And then you got your subnet mask. Okay, so now remember we can keep it as a /24 or we can do a /25 all the way to a /31. So I can choose what I want to do here, but let's say that one of my customers needs a /26. So first thing I can do is go write out 26 ones. And then subtract the subnet mask. And so we're masking it, so this is still zeros in our case. And we got 11.46.21.0/26. And we know from this portion that it's 2 or in this section here. So this is, so if we flip these over now, flip them over, we got 0, oops, let's have 6 here. So now we got 6 ones. So what does 6 ones give us? 1, 2, 3, 4, 5, 6. So if we add those up, we got 32 plus 16 plus 8 plus 4 plus 2 plus 1, 63. So 0.0.0.63. We can add that. So now our first subnet is 11.46.21.0 to 11.46.21.63, or we can also write it as 11.46.21.0/26. So now we can take this address, the .63, so we know the next available network is .64. So next available is 11.46.21.64. Now this can be a /26. We want to do it that way, and we can end up with 4 times /26 networks, or we can split this further. So it gets tricky, but say the next network is from 64 to 127, right? Because they're all 64 wide. So imagine that we wanted to break this piece down into smaller pieces for many other customers. So we could write this one out as 100001011 .64. So the write out 64 is basically just 1. So 010000000. And our subnet mask, which now is at /26. Oops, 24. So now we can subtract that, and we can end up here 11.46.21. And now in this case, we'll have to figure this one out. So it'll be 010000000. So dot. Oh, what am I doing? So that's 64. So this is not what I wanted. So let's say actually we're splitting this network. We're gonna make this into a bunch of /27s. So I'm gonna write out a /27. And we still get the same answer. So now this network is a /27. And this is still 64. But now if we continue to the next page, we don't have the next page. So let's make another page. So 11.46. So now we're saying 11.46.21. So we were 11.46.21.0/24, and we split it, and we made an 11.46.21.0/26, and we made 11.46.21.64/26, and 11.46.21.28/26, and 11.46.21.192/26. And then we took, so this one, say we sold it to a customer, and this one we're gonna make it into /30s. So we're just gonna keep it, and the way we do that with our boxes. So it always goes smaller. So we're gonna write this out again. So 11, so 0.00008. 21, so 0.0001. 64. Is that correct? Yes. So now /30, we're gonna go 1, 2, 3, 4, 5, 6, 7, 8, 16, 24. I better do this neater. So that it lines up. It's 24, 25, 26, 27, 28, 29, 30. So now, if I mask it, I get so I'm writing the 0, the 1, the 0, the 0, the 0, the 0, the 0, and the last two zeros, I'm hiding them, but they're still zeros, so we still end up with 11.46.21.64 is a /30. So if we flip the mask over, we end up with 11 at the end, which is actually translates into 0.0.0.2 and 1. So that's 3. So I can add this. So now I have 11.46.21.64 plus 3, which is 67. So that becomes my first my end network. So diagram. So that's not correct. So should write that as 11. So this should say 64. So this is our first network. That's a /30. So we've created 4 /26s, but we took 1 /26 and we made it into /30s. So it starts at 64 and it ends at 67. So plus 3. In other words, 11.46.21.64 to 46.21.67 slash, no slash here. And then we can write out our next network and just add 4. And we know it's 4 because 2 to the x equals 2 to the 2, because there's 2 zeros here, so that's 4. So 68/30. And we know that the original width of this was only 64. So 64 divided by 4 is 16. So we only have 16 of these networks. And if we wanted to know what the last one was, we know that 64. So our last number in this whole thing was 11.46.21.127. And if you go back 3, so the last one will be 11.46.21.124. Because 4, 5, 6, 7. So the start of your network's always even, the end of your network's always odd. So this is /30. And there are 16 of these. You don't believe me. So that's subnetting in a nutshell. Thank you.